Hello everyone, welcome to this video. In this video, we shall be looking at a question from IIT-JAM 2019 consisting of 1 mark, and this is a numerical type of answer, right? So the question here is, if vector f, this is defined to be minus y I cap plus x j cap, and the curve C is defined to be the ellipse whose equation is this x square divided by 16 plus y square divided by 9 is equal to 1, oriented in the counterclockwise direction, that means the anti-clockwise direction, then we are to determine what is the value of this line integral when you take the dot product of this vector f with the positional vector dr, right? So let's get started with the solution to this question. So in this solution here, we are to calculate this line integral over this given ellipse C, and we are given we are asked to calculate f dot with the vector dr. Now first of all, let us visualize this curve C. How does it look like? So all of you know how to draw this ellipse over here, right? This is the x-axis, this is the y-axis, and the equation for ellipse is x square by a square plus y square by b square is equal to 1. This is the general equation, where a is the distance which is covered from origin in the x direction, and this is the a distance, and similarly this distance is the b distance. So here in our case, what is a? A here is 4 and b here is 3. So we have a distance of 4 here and a distance of 3 here from the origin. So that means your ellipse will pass through these 4 points and will look something like this, right? It would be more continuous and smooth, right? So this is our ellipse, and we are to traverse it in the anti-clockwise direction. So this is the direction. So now one way to solve this is using Stokes' theorem, which is the one way I am using here. So in Stokes' theorem, what we do, we convert this line integral into the corresponding double integral, surface integral. So its formula become the double integral over the given surface S. So what would be your surface? Your surface would be the one which is being covered by this ellipse, right? So within this ellipse, whatever is the area, that is your surface. So in this surface, you are to calculate what is your double integral, and the double integral now is calculated for del cross with the vector f, and you are to take the dot product of this thing with the vector n cap, which is the unit vector perpendicular to the direction of this plane. Now this is x plane, this is y plane, so what would be the direction perpendicular to it? So it would be the vector which is coming out of the screen or going inside of the screen. So in this way, because we are traversing in the anti-clockwise direction, so the direction has to be the positive z direction, so which would come out of the screen. So here your n vector would simply be the unit vector in the direction of z axis, which is k cap, right? So k cap, and we have to write here ds, the surface integral. Okay, so now we know what is n, we have f, we know what is del. What is del? It is del by del x I cap plus del by del y j cap plus del by del z k cap. So accordingly, we can compute this cross product over here. So let me first compute del cross vector f. So for that, I am writing I cap, j cap, k cap. Then the components for del vector, which are del by del x, del by del y, del by del z, and then the components for f vector, which are minus y, x and 0. So we have minus y, x and 0. So we are to solve this determinant here. So it would be I cap. So here you would apply this operator onto this and this onto this. So you have 0 here because these are the partial derivatives, and then we have we'll perform del by del x of 0, right, minus del by del z of minus y, and then we'll perform plus k cap of del by del x of x minus del by del y of minus y. So here in this case you cannot just simply multiply these two because this is the operator over here. So you have to apply this operator onto this given function. Okay, so now you see the component for I vector is 0, the component for j vector is also 0. For k vector it is 1 plus 1, so that is 2 k cap. So we have 2 k cap as this cross product. So you obtain del cross f vector as 2k cap. Now we are to apply the dot product of this vector with the vector n. Remember here what is n? N is k. So we'll be taking the dot product of vector n. So it would be del cross vector f dot with vector k. So what is its value? It is 2k cap. So 2k cap dot with k cap. Now they both are unit vectors and they are in the same direction. So its value is k dot k is 1. So we have 2 here. So this whole term reduces to this 2. So therefore our integral becomes equal to double integral over the given surface 2 ds. So that is so simple to solve. Now let's compute this. So in order to calculate this surface integral, we'll convert that into xy coordinates. So it would be 2 could be taken outside, so it would be s ds. So now I can write this to be dx and dy. So I have to write the limits of x here and the limits of y here. So in order to write the limits of x, what I have to do, I have to take a horizontal line which is crossing this region. So I have to see what is the value of x here and what is the value of x here, and the limits for y, they would vary from here to here. So you already know what is the value of y here at this point. At this point the value of y is 3, at this point the value of y is minus 3, right? So we know the constant limits for y, they are from minus 3 to 3. Now in order to look for the limits for x, we have to go back to the equation of the ellipse. So this was the equation of ellipse. From here, what is the value of x? So it would be plus minus 4 into square root of 1 minus y square by 9, right? So this is the value of x. So the lower value of x would be the negative side. So it would be the negative quantity because we are on the left side of origin, right? So accordingly x would be minus 4 square root of 1 minus y square by 9, and it would be plus 4 square root of 1 minus y square by 9. So now we have to compute this integral. Now here we have 1. So basically this is a even function. So we may rewrite our equation as 2 into 2 into 2 multiplied by integration from 0 to 3, integration from 0 to 4, square root of 1 minus y square by 9, 1 dx dy. Now we'll perform the integration with respect to x first, solving this much part. So we have 8 into integration from 0 to 3, and so it would just be x, and we'll substitute the limits for x. They would be from 0 to 4 square root of 1 minus y square by 9 dy as such. So when you substitute the limits for y, it would be 4 square root of 1 minus y square by 9 dy. Now you could also take this y common from here, so it would be 32 divided by 3, right? Integration from 0 to 3, square root of 9 minus y square dy. Now here we have to use this formula of integration. All of you might be knowing this. So what is the integration of a square minus x square dx? It is equal to x by 2 square root of a square minus x square, right, plus a square by 2 sine inverse of x upon a. So here in our case, what is a? A is 3, right? So therefore our formula here becomes 32 by 3 as such, and then you have After performing this integration, it would be y by 2 square root of 9 minus y square. This is the first term, and the second term is 9 by 2 sine inverse of y by 3, right? And the limits of integration, they are from 0 to 3. So next task is to substitute the limits of integration. What would be that? So first of all, you will substitute 3. So you will be having y by 2 square root of 9 minus 9. So this term would be 0. And then you will substitute 3 again. So it would be 3 by 3. And then you will substitute 0. So minus of, here you have 0. So 0 into something is 0. And then you have 9 by 2 sine inverse of 0. Sine inverse of 0 is again 0. So we are only left with this term is 0. This term is 0, this term is also 0, because sine inverse of 0 is 0. So we are left only with this term. So that is 9 by 2 sine inverse of 1. And you know what is sine inverse of 1? That is pi by 2. So that is 32 into 9 divided by 3 into 2 into pi by 2. So you see, this 9 and 3 cancels out. This and this cancels out. So 4 by 3, that is 8. So we are left with 24 pi. Now when you substitute the value of 3 pi here, 3.14 or another approximation, so your answer would be something near to 75.4, right? So or 40, right? So this would be your final answer, because you are required to calculate this answer in the numerical answer type up to 2 decimal places correct. So this is your final answer, 75.40. So let's substitute it here, 75.40. So this is your final answer. I hope you understood this question well. Well, that is it for this video. Thank you for watching.